I want to now solve another exponential equation. And once again, because I'm going to have variables in my exponent, the way I'm going to go about solving this is by using our good friend, the logarithm. So here I have 3 to the x plus 4 equals 2 to the 1 minus 3x. And I'm trying to solve this equation for x. I'm trying to determine what value of x will make this equation true. Now we had done some problems like this earlier in the chapter, except in those cases either the bases were the same or we were able to get the bases to be the same. But right here I have a base 3 and base 2. They're not the same, and there's no way I can make them to be the same. So here I'm going to actually take the log of both sides. It's my choice. I can take log base 10 or natural log. I'll just go ahead and do log base 10. So once again, I can do whatever I want to this equation as long as I do the same thing to both sides. And now I'm going to use the rule for when you have exponents inside of a log, that you can move the exponent in front and make it a coefficient. So I have x plus 4 times log 3 and 1 minus 3x times log 2. Now I need to solve for x. So the good thing is now I've gotten the variable x out of the exponent and down into the expression, but now I have some work to do. So I'm going to multiply out, this is not going to be like a linear equation. I'm going to multiply out the parentheses, get all the terms with x on one side, all the terms without an x on the other side, and then try and solve for x. So I'm going to have x log 3 plus 4 log 3 on the left side. On the right side, log 2 minus 3x log 2. So let's just go ahead and let's get my logs on the left-hand side. So I have x log 3 plus 3x log 2 equals log 2 minus 4 log 3. And now on the left-hand side, let's go ahead and factor out an x so I can solve for it. X, so log 3 plus 3 log 2 equals log 2 minus 4 log 3. So now I'll divide both sides by this parenthesis, and I get x equal to log 2 minus 4 log 3 over log 3 plus 3 log 2. Now at this point, you could actually grab your calculator and actually figure out the answer. But just for fun, let's use some of our rules about when you're adding or subtracting logs, combine them into one log, and let's just make this look a little simpler. First thing I'll do is this 4 here, I'll move it up here, and the 3, I'll move it up here. So then now I'm going to say x is log of 2 over 3 to the 4th is 9.7. And then on the bottom, log of 3 times 8, which is 24, so actually now I can grab my calculator. I take 2 divided by 81 equals, I take the log of that, divided by 24, the log, that equals negative 1.16. Now don't forget that I rounded this off, and I could also do this problem with natural logs, but I chose to do it with log base 10. So once again, what we've done here is we had an equation that began with having variables in the exponent, and the way we were able to solve for this, the way we can get at those variables is by taking the log of both sides. And then we go from there, and we're able to solve it, and there you go. So hopefully you won't have too much difficulty with this.